Hello and welcome back to the channel. In this course, we're going to be looking at an introduction to Unix. To get started with a Unix system, there are several popular distributions you can choose from. Mainly, they're divided into Debian and Red Hat families. Under the Red Hat family, we have CentOS, Alma Linux, Rocky Linux, and more. Under the Debian family, the more popular option is Ubuntu. Throughout this course, we're going to be using the Ubuntu distribution. When it comes to installing Linux or Unix, you have three options. The first option is the bare metal installation. This is going to involve installing the operating system directly onto your computer. It is going to provide you with full access to the hardware resources of your computer, and it's going to also provide good performance. Now, the downside to this is that you might have to uninstall your existing operating system, or you'd have to share resources between two different operating systems. The second option is using a virtual machine. With virtualization software like VirtualBox, you can create and run multiple virtual machines on a single computer. Each virtual machine is going to act as an independent computer, and this is going to allow you to install and run Linux or Unix alongside your current operating system. This is the option that we recommend for this course, and if you want a step-by-step guide on how to set up VirtualBox, I'll be putting a video in the description below, or you can access it in the card at the top right. The third option you have is using a cloud computing platform. Cloud computing platforms such as Amazon's Web Services, Microsoft Azure, and Google Cloud Platform offer virtualized computing resources on demand over the internet, and you can deploy your Linux or Unix instances or virtual servers in the cloud, where you're going to pay for the resources you used based on how much you're using the machine. And the obvious downside to this is that you're going to have to pay. A shell is a command line interpreter that is used to launch different software in Linux systems. There are different shells available like Bash, CSH, ZSH, and more. In this course, we're going to be using the most popular shell, which is the Bash shell. We're going to be spending most of our time in the command line. The command line is preferred over the graphical user interface because of different features like autocomplete, configuration management, aliasing, and automation capabilities. To get to the shell, you're going to search for the terminal application on your computer. When you open it up, you should be met with this kind of prompt. The first part of the prompt is going to be the currently logged in user's username. Then we're going to have the @ character followed by the computer's name. And after the colon, you're going to have the currently working directory, followed by a $sign. Most likely when you open the terminal for the first time, you're going to be in the home directory of the current user, which is represented by the tilde character. Before we run our first command, my prompt might look a bit different from yours. That is because I'm using a theme, but all the commands we're going to run should work the same. So the first command we're going to see in this section is the ls command. So we're going to type in ls and press enter. What this command does is it lists all the files and folders in your current directory. Now the ls command has a command line output, but there are other commands that have a graphical output, like the xeyes command. So if we run the xeyes command, we get a graphical output. One thing to note here is that while another command is running, you cannot input another command. As you can see, the prompt has not appeared yet where we can enter commands, but if we exit out of the graphical output, then our prompt reappears. All the commands we're going to see throughout this course are going to have the following structure. Switches, which are also known as options or flags, allow the user to customize the behavior of a command. They usually start with a hyphen or a double hyphen and can be used to enable or disable certain features of a command. And when it comes to arguments, they're basically inputs that we give to the command that we want to use. For example, the ls command we just saw accepts an L switch. So we can have ls followed by a hyphen, then the letter L. Just like before, this is going to print out the folders and files in our current directory, but this time more information is included, like the file's permissions, the owner of the file, the size of the file, and the date the files were created. Arguments, on the other hand, are inputs provided to a command. So the ls command also accepts arguments. So we can have ls followed by a slash. What this is going to do is it's going to list out all the folders and files in the root directory. So if we press enter, we can see that we get a different output. This is because we provided an argument, and the ls command is going to take this argument and it's going to list out the files and folders that are located inside the argument we provided. Now, different commands can have different switches and arguments. And to get information about a specific command, we're going to use a command called man. To use it, we're going to type in man, followed by the command we want to know more information about. So we can pass in the ls command. As you can see in this window, we get how the ls command works, how we can use it. We get a short description of what the ls command does, and we also get a list of the different options. And to exit out of this manual page, we simply have to press Q. There is also another alternative to get information about a command, and that is using the help option. So we can type in ls followed by double hyphen and the word help. Again, this is going to display how to use the ls command, the different options, and a short description. The file system in Unix is a bit different from the one we're used to in Windows. In Unix, there are no drive letters, so different drives are simply represented by directories, and they can exist anywhere in the file system. And another difference is that file extensions like .txt can be used, but they are not required. Now let's look at a simple Unix file system. So at the top we have the root directory. And inside the root directory, we have the home directory. And inside the home, we have John. And inside John, we have documents. And inside documents, we have test.txt. One important thing to note here is that file names are case sensitive. So test.txt would be different from test.txt with a capital T. To see the location of the working directory in relation to the root, we can use the command pwd. So this is where we're currently located. To change our current directory, we can use the command cd. So we can have cd followed by desktop. And this is going to move us to the desktop. And to check this, we can run the pwd command again. And we can see that our path has been updated. Now the cd command can be used in different ways. If we type in the cd command alone and press enter, it's going to take us back to our home directory. We can also have cd followed by a hyphen. This is going to take us back to the previous directory that we were in, which in our case was the desktop directory. So if we press enter, we go back to the desktop. Finally, we can have cd followed by 2 dots. This command is going to take us back to our parent directory. So in our case, it's going to take us back to our home directory. So if we press enter, we move back to the parent directory. One more thing we can see in this section is absolute and relative paths. An absolute path is the address of a file from the root, which is the output that we get when using the pwd command. When it comes to relative path, that is the address of a file from the current directory. So for example, the relative path to the desktop folder is going to be dot, which is the current directory. Then we're going to have a slash followed by desktop. A quick way to be able to specify multiple files is using wildcards. There are two main wildcards that we're going to be using. The first one is asterisk, which represents any number of any character. We also have question mark, which is used to represent one of any character. So to see this, we're going to navigate to the folder called Monday, and we're going to use the ls command. As you can see, we have different files. So let's say we wanted to list out all the files that have a .txt extension. In order to do that, we would type in ls followed by an asterisk, then .txt. Now if we press enter, we get all the files that have a .txt extension. So the asterisk is used to represent any number of any character. Now let's say we wanted to target text files that start with mon underscore and have a single character. So that would be mon underscore 1.txt and mon underscore 2.txt. So in order to target these files, we would have ls followed by mon underscore, then we're going to have question mark .txt. So here the question mark character is used to represent only a single character. That means mon underscore 12 and mon underscore 21 are not matched. Instead, if we used ls mon underscore asterisk, then all the mon underscore files would have been matched. Most of the operations done in a Linux system deal with file manipulation. A file can be viewed, edited, moved, renamed, copied, deleted, or found. To view the contents of a file, we're going to use the command cat. So we can pass in cat and give it an argument. Let's give it the file a.txt. And when we press enter, the contents of the file a.txt gets displayed. Another way to view the contents of a file is using the head and tail command. So first let's use the cat command to see what's inside b.txt. As you can see, we have some letters, and using the head command and providing a number, let's say we provide 3, and we're going to pass in b.txt. Now this is going to display the first 3 lines of the file b.txt. And using the tail command, again, we can pass in any number. Let's pass in 5 and pass in b.txt. Now this is going to display the last 5 lines of the file b.txt. To edit the contents of a file, we need to use a text editor. You can use any text editor of your choice. For now, we're going to use Nano, but there are other editors that we're going to see throughout this course, like VI and Emacs. To use Nano, we're going to type in nano, followed by the name of the file. We're going to pass in c.txt. And in this window, we can type in whatever we want. So we can type in hello world. From the shortcuts below, we can see that to exit out, we're going to use Ctrl+X. It's going to ask us if we want to save the changes. We're going to type in Y. And we're going to confirm the file that we want to write to by pressing enter. And now we've returned to our prompt. Now to check that we've written to this file, we can use the cat command. And hello world gets displayed. To move and rename files, we use the same command, which is mv. When using the mv command, if we pass in a new name, then the file is going to get renamed. And if we provide a location, then the file is going to get moved. For example, we can rename our c.txt file to 123.txt and press enter. Now if we use the ls command, we can see that instead of c.txt, we have 123.txt. Now if we use the mv command again, but instead of passing in a new name, if we pass in a location, we're going to pass in our home directory and press enter. Now if we use the ls command, 123.txt is no longer here. But if we navigate back to our home directory and use the ls command, we can see that 123.txt has been moved here. To copy files, we're going to use the cp command. So we're going to have cp followed by a file that we want to copy. Let's put in a.txt. And the second argument is going to be the name of our copy. We can give it abcd.txt. We can also provide a location. We can do that by adding a location before the new name. So here we can add our home directory. So this is going to copy the file a.txt to our home directory, and it's going to give it the name abcd.txt. So now if we head back to our home directory and use the ls command, we can see that we have abcd.txt. When we want to delete files, we're going to use the rm command, but you need to be careful using this command since the files you delete are not going to go to your recycle bin. There are two versions of the rm command we're going to use. When we want to delete a file, we're going to use rm followed by the file name. And now if we use the ls command, abcd.txt has been deleted. Now let's make a new directory called Tuesday. Now if we want to delete the Tuesday directory, we're going to use the rm command. But this time we need to provide an option, which is the R option. Now we can pass in Tuesday. And if we use the ls command, we can see that Tuesday has been deleted. There are three types of permissions we can control. Read, which refers to who can view the contents of a file. Write, which refers to who can modify the contents of a file. And execute, which refers to who can use the file as a command. We also have three categories of users. The first is the user or owner of the file, which is represented by U. The second is the group, which is represented by G. And finally, we have others, which is represented by O. To modify permissions of a file, we use the following command. When using the change mod command, we have two ways of providing options. The first way is by providing a specific sequence of 3 digits in the range of 0 to 7. The first digit is going to represent the permissions of the user or the owner. The second digit is going to represent the permissions of the group. And the third digit is going to represent the permissions of others. The different permissions are represented by different numbers. The read permission is represented by the number 4. The write permission by the number 2, the execute permission by the number 1, and no permissions is represented by the number 0. So if we wanted to give a user the read and the write permissions, we would add the two numbers, which is 4 and 2, and we would pass in the number 6. As we saw in the previous section, to view the different permissions of a file, we can use the ls command with the L option. So let's say we wanted to give the owner of the file all three permissions, that is read, write, and execute. And we wanted to give the group read and write permissions only, but not execute permissions. And for others, we wanted to give them the permission to only read the file. So we're going to use the change mod command. And the first digit is for the owner of the file. Since we want to give them all the permissions, we're going to add the number for read, write, and execute, which is going to be 7. For the group, we wanted to give them read and write permissions. So we're going to add 4 and 2, so we're going to have 6. And for the others, we want to give them only read permissions, so we're going to have 4. Next, we're going to provide an argument, which is going to be the file we want to modify. And in our case, we're going to pass in a.txt. So originally, as you can see, the owner of the file has read and write permissions only. The group also has read and write permissions only, and others have read permission only. But after we run our command, if we use ls-l again, we can see that the owner of the file has read, write, and execute permissions. The group has read and write permissions only, and others have read permission only. The second way of providing options to the change mod command is using characters. So to give the same permissions as we did before, we're going to have change mod. For the owner, we wanted to give all the permissions, so we're going to have u equals to rwx. Then we're going to have a comma. And for the group, we wanted the permissions to read and write. And for others, we wanted the permission to read only. Now we can apply this permissions to b.txt and press enter. And if we run ls-l, we can see that we have the same permissions. Another thing you can do with this is you can add and remove permissions. So for example, we can have change mod. And if we wanted to remove the execute permission from the user, we would have u minus x followed by the name of the file. We're going to pass in a.txt. And now if we ran ls-l, we can see that the owner no longer has execute permissions. Using the same syntax, we can add permissions. So we can have change mod. Let's say we wanted to add execute permissions to the group. So we would have g plus x followed by the name of the file. We're going to pass in a.txt and press enter. And if we run ls-l, we can see that the group now has executing permissions. There are three ways we can use to find files that we don't know the exact location of. The first method is using the find command. So we're going to follow the syntax find followed by a directory. Then we're going to have -name followed by our target. And we're going to have -print. So here the directory is where we want to search, and the name option is going to let us provide a target or the name of the file we want to search. And finally, the print option is going to display the output to the terminal. So let's say we wanted to find a file inside the home directory, and we're going to have the name option, and we want to find files with the .txt extension. So we're going to use a wildcard followed by .txt, and finally we're going to give it the print option. Now if we press enter, we get a display of all the text files that are located inside the home directory. One thing to note here is that we're not only searching the top level of the home directory, we're also going to search inside all the directories that are located inside home. The find command does not only work with names, you can also search by type using the type option, or by permission using the perm option. You can look more into this by using the man command. The second method of finding files is using the which command. So if you can execute a command by typing its name, then you can find the location of that command using the which command. So a command we've been using a lot is the ls command. So we can find its location by passing it to which and pressing enter. Then we can see where the ls command is located. The third and final method is using the locate command. For example, if we wanted to find all the text files, we can put in locate, and we're going to give it .txt. And if we press enter, it's going to display all the text files that are found inside our system. But when using the locate command, there are several disadvantages. One of the disadvantages is that it is updated once per day, so you might not be able to find files that have been recently created. Another disadvantage is that unlike the find command, you cannot use file type or file permissions to base your search. To search for specific text or pattern in a file, we use the grep command. The syntax we're going to use is grep followed by options, followed by a pattern and a file name. Some of the useful options you can use with grep is the -c option. This is going to print out a count of the number of lines that match. You can use -i. This is going to make your search case insensitive. You can use -v, which is going to print out the lines that don't match the pattern you provided. When you want to provide a pattern to the grep command, we use regular expressions. When using regular expressions, you define a pattern of a list of characters using square brackets. So if you wanted to match the characters from A to P, you would pass in A-P. So this would match all the characters from A to P. You can also use numbers. So if you wanted to match the numbers from 0 to 5, you can pass in 0-5. Other special characters you can use with regular expressions are the $sign. This is going to match to the end of a file. So for example, if you had L followed by a $sign, this is going to match all the lines that end with the letter L. You can also have the caret character, and this is the opposite of the $sign. This is going to match the beginning of a line. So if you had caret A, it's going to match all the lines that begin with the character A. Now to see this in practice, let's look at the file D. First, we're going to see the contents using the cat command. As you can see, we have some random sentences. So let's say we wanted to find the lines that begin with a capital T. So we're going to have grep, and we're not going to provide any options. And for the pattern, we're going to pass in caret followed by a capital T. Then we're going to pass in the name of our file, which is D. And now if we press enter, we see that the two lines that begin with a capital T have been returned. Let's look at another example. We're going to have grep, caret, and we're going to pass in a range of characters. So let's say we want to match the characters from A to I. And we're going to pass in the name of our file, which is D. So this should return the lines that start with the characters from A to I. So if we press enter, we get the lines that begin with the letters from A to I. The pipe operator is used to give the output of one command as input to another command. To see this, let's look at the file called E. To see the contents, we're going to use the cat command. As you can see, we have a list of random letters. So now we can have cat E again, but instead of simply pressing enter, we're going to use the pipe operator, and we're going to pass in the output of cat to the sort command. And now if we press enter, we can see that the letters have been displayed, but this time they're sorted. Now you can have multiple commands in the chain. So for example, if we run the command again, but instead we pass in another pipe and we give it the command unique, this time it's going to display the sorted letters without any duplicates. The output from programs are usually written to the terminal, which is referred to as the standard output, and our keyboard is referred to as the standard input. Using input-output redirection, we can redirect the output to a file instead of the standard output. And to do that, we're going to use the greater than sign. So for example, the echo command simply displays out the text we give it to the standard output. So if we give it hello, we get hello in the standard output. But now if we use input-output redirection using the greater than sign, we can pass it to a file. So let's just pass it to the file hello.txt. And if we press enter, we see nothing in the terminal. That is because the output has been redirected. And if we use the cat command to view the contents of the hello.txt file, we can see that we have hello. Now if we run the command again, but instead we're going to have echo world, and if we press enter, and if we see the contents of the hello.txt file, we can see that hello has been overwritten and now we only have world. Instead of overwriting everything, if we want to append to a file, we're going to use double greater than signs. So we can have echo hello, and instead of having a single greater than sign, we're going to pass in two greater than signs, and now we can pass in hello.txt. And if we use the cat command again, we can see that it hasn't been overwritten. Instead, it has been appended. When it comes to input redirection, we do not use it as much as we use output redirection. But as an example, we can use it with the cat command. And to use input redirection, we're going to have a less than sign. Then we're going to have a file. We can pass in hello.txt. So this is going to work the same, but the difference is that when using cat hello.txt, this time we're passing in hello.txt as an argument, but when we are using the less than sign, we are using redirection instead. Job control lets us control different processes at the same time. For example, if you're editing a text file and want to interrupt your editing and do something else, using job control, you can suspend the editor, go back to the shell prompt, do your work, and switch back to the editor. Jobs can either be in the foreground or in the background, and there can only be one job in the foreground at any time. The job in the foreground has control of the shell and gets input from the keyboard and sends output to the screen, while the job in the background does not have access to these controls. We can temporarily suspend a job in the foreground using the shortcut Ctrl+Z, and to bring the job back to the foreground, we can type in FG and press Enter, or we can move it to the background by typing BG and pressing Enter. To see this in practice, we're going to use the nano command. So we're going to have nano followed by a file name. We're going to call it text1. And if we press enter, it's going to take us to the text editor. And here we can type in our text. And if we want to return back to the prompt and run other commands, we're going to press Ctrl+Z. Now when using nano, it's going to tell you to suspend. You have to type Ctrl+T first. So we're going to have Ctrl+T followed by Ctrl+Z. And now we've returned back to the prompt. So from here, we can create another file using nano. We're going to call it text2. And we can press enter. And again, we can pass in some text and use Ctrl+T followed by Ctrl+Z to suspend our task and go back to the prompt. Let's do this one more time, and we're going to create a file called text3, and we're going to put in some text, and we're going to suspend the operation using Ctrl+T followed by Ctrl+Z. Now to see the different jobs we have, we can use the jobs command, and if we press enter, we can see that we have 3 jobs listed. So let's say we wanted to go back to text2. In order to do that, we're going to use the FG command, which stands for foreground, and we're going to pass in % followed by the number associated with the operation we want to go to. So for text2, we're going to use the number 2. So if we press enter, then it's going to take us back to the text2 file. Again, we can suspend this, and if we want to go to the first text file, we can pass in FG followed by %1, and if we press enter, we go back to the first file. Once we are done, if we want to delete a process or an operation, we're going to use the kill command with the option 9, and here we can pass in the number of the operation. So for example, if we wanted to delete the first operation and the third operation, we would pass in %1 and %3. And if we press enter, we can see that operations 1 and 3 have been removed. So if we run the command jobs again, only the second job remains. Now to see how the background works, we're going to look at another example. So we're going to have a Python command. So we're going to have Python3 with the C option, and in quotations, we're going to import the time module, and we're going to run time.sleep, and we're going to pass in 5 seconds, and we're going to print hello world. Now if we simply press enter, our prompt disappears and we have to wait 5 seconds till the process finishes and hello world gets displayed. But if we wanted to run this operation in the background, we simply add the ampersand character at the end of our command. And now if we press enter, our prompt is still here, so we can type in different commands, and after 5 seconds, the output gets displayed. So ping is a utility that checks the round-trip response time between two machines. For example, we can ping the Cloudflare server, which is located at 1.1.1.1. After seeing a few responses, we can exit out using the Ctrl-C shortcut. From the ping command, we can get different information like packet loss and the time it takes to get a response from a remote machine. Another command related to ping is the traceroute command. This command shows you the full path taken to reach a remote machine. This command is particularly useful for tracking down the location of different network problems. A command called FTP is an insecure way of transferring files between computers. If you are able to connect to a machine using the FTP command, you can list the different files using the ls command, and you can receive files using the get command, and when you want to send files, you can use the put command. However, you should not forget that this is the insecure way of transferring files, and you should not be using it. The secure version of FTP is SCP. It works like the CP command, but instead of getting the original files, you get a copy of the files. Other internet-related utilities we can mention are Netscape, which is a full-fledged graphical web browser, Lynx, which provides a way to browse the web on a text-only terminal, and wget, which provides a way of receiving files from the web. CVS is a source code control system, which is used when dealing with large projects that are being edited by multiple people. It keeps old versions of files and maintains a log of when, why, and who made the changes. To use CVS, we have to first install it using the command sudo apt install CVS. CVS has a large set of commands which we can view using the command info space CVS. But the main commands you're going to be using are, the first one is CVS checkout. This command gives you a private copy of the source code, which you can work on without interfering with others. The second command is CVS update. This command is going to update your code to include changes that other developers have made. And another command is CVS add. This command is going to add new files that you have checked out from the project. The changes are not going to be seen in the project until you run the command cvs commit, and the final command you need to know is cvs remove. This command is going to allow you to remove files that you have checked out from the project, but again, this does not take effect until you run the cvs commit command. So basically, CVS is a source code control system that is very similar to Git, which is a very popular version control system. In this section, we're going to look at the two most popular editors in Unix, which are VI and emacs. VI is a display-oriented text editor, and even though it might be a bit complex to use, it's useful to know since it's universally available on all Unix systems. The first command we're going to look at is vi followed by a file name. So we can pass in test.txt. So if this file exists, it's going to get opened. And if it doesn't exist, it's going to get created and opened. In our case, it does not exist, so it's going to get created. Once we're inside the VI editor, we have two modes, the command mode and the input mode. When you first enter a file, by default, you're going to be inside the command mode. In the command mode, characters you type perform actions like moving your cursor, cutting, or copying. And when you're inside the input mode, characters you type are inserted into the file. Now to put our VI editor into insert mode, we simply press I. And at the bottom, we can see that it says insert. Now we can type text into our file. And once we're done, to go back to the command mode, we're going to press the escape button. And as you can see, the insert word disappears. So while you're in the command mode, you can move your cursor using the arrow key. Other useful keys are the caret key, which is going to take you to the beginning of a file, and the $sign key, which is going to take you to the end of a file. W is going to skip to the beginning of the next word. So if we press W, we go to the beginning of the next word. And B is going to be the reverse. So it's going to take you to the beginning of the previous word. And finally, to exit and save your file, you're simply going to press Shift plus colon, which is going to give you a place you can put in a command. In our case, we're going to put in X, which stands for save and exit. And if we press enter, we head back to our prompt. And now we can use the cat command to see the contents of test.txt, and we can see that hello world has been added. The second editor we're going to look at is Emacs. Emacs is a popular editor for Unix, Windows, and Mac, but unlike VI, it is not a standard Unix system utility, so you're going to have to install it. To install Emacs, you're going to use the command sudo apt install emacs, and it's going to prompt you for your sudo password. And once that's done, it's going to install Emacs to your system. To get started with Emacs, we're going to use the command emacs followed by a file name. Let's give it test2.txt. And if we press enter, then we get a graphical user interface. So Emacs has a graphical interface which makes it easier to use. It also includes multiple shortcuts to save files and exit out of Emacs. So for example, we're going to add some text. And if we go over to File, we can see that we have different actions and their associated shortcut. So for example, to quit, the shortcut is going to be Ctrl X plus Ctrl C. So the C-X followed by C-C means that you have to press Ctrl X followed by Ctrl C. So we're going to press that shortcut. It's going to ask us if we want to save the file. We're going to press Y. And now our file has been saved, which we can verify using the cat command. And we get the text hello. So basically, for simple text editing, you're going to use the VI text editor. But when it comes to bigger projects, the Emacs editor is more useful. The super user is a privileged user who has unrestricted access to all commands and files on a system, regardless of their permissions. The super user's login is usually root, and access to the root account is restricted by a password. Now, you have to be careful when entering commands as a super user. For example, if you enter the command to remove all text files, which is the following command, but accidentally if you add a space between the asterisk and the file extension, now this command is going to delete all the files and directories in the current folder. To become a super user, you can use the su command, but a safer method to use is when you want to run a specific command as a root user, you're going to use the sudo command followed by the command you want to run. When you have multiple people using the same machine, you can assign them to different users. To create a user, we're going to use the command sudo, which is going to give us administrative privileges, and we're going to use the command user add, followed by a username. Once we've created a user, we can assign it a password using the command sudo passwd, followed by the username which we want to give a password to. And finally, if you want to delete a user, you can use the command sudo userdel, followed by the username which you want to delete. Now previously we saw that we can have 3 categories of users, and one of those was a group. A group is a collection of users with similar permissions. So we can provide a group specific permissions and we can add users to that group. Now to create a group, we're going to use the command group add, followed by the name of the group. And to add users to a group, we're going to use the command usermod, followed by the options AG. Then we're going to input the group name, followed by the username which we want to add to the group. Now the AG flag here stands for append and add to supplementary groups. This is going to ensure that we add the user to a group without overwriting the primary groups that the user is already a part of. And to check the groups that a user is in, we can use the command groups followed by the username. Finally, let's see one more command that is used to change the group ownership of a file. So to change the group ownership of, let's say, a file called hello.txt, we would use the command sudo change ownership followed by a colon, then the name of the group we want to give the permission to, followed by the name of the file. To see this in practice, let's create a new user. So we're going to have sudo user add, and we're going to call it John. Next, we're going to give it a password using the passwd command, and we're going to pass in John. And for simplicity, we're going to give it 123. It's going to tell us that it is a bad password, but for demonstrations, again, we're going to type in 123 and press enter. Once our user has been created, let's look at the files we have in the current directory. If we look at the first file, which is a.txt, we can see that the group currently has read, write, and execute permissions. And we want to change that so that the group only has read permissions. So in order to do that, we're going to run the command change mod. And we want to modify the group, and we're going to set it equal to R. And we're going to pass in the file name. So now if we run ls-l, we can see that the group only has read permissions. Next, we're going to create a new group called test. So we're going to run the command sudo group add, followed by test. Then we're going to add the new user we created, which is John, to the group test. So we're going to run the command sudo usermod, followed by the AG option. Then we're going to provide the group name, which is test, and the user we want to add, which is John. The final thing we're going to do is we're going to change the group ownership of the a.txt file to the new group we created. And in order to do that, we're going to run the change ownership command. And the group we want to give permission to is and finally, we're going to pass in the name of the file. Now to test the permissions out, we're going to switch to the John user. And in order to do that, you're going to use the su command, followed by the user you want to switch to, which in our case is John. It's going to ask us for the password. We're going to put in 123. And now we're inside the user John. Now to make sure that the user has been switched, you can run the command whoami, and if you press enter, it should give you John. So now we're going to list out the different files we have using the ls command. And if we try to read the contents of a.txt using the cat command, it should work since we have read permissions. But if we try to write to the file, for example, using the cat command, you can redirect the output to a file. So this is how you would write to the file a.txt using the cat command. And if we press enter, we get permission denied. This is because the group that John is a part of only have read permissions. A shell is a program which reads and executes command for the user. And like most programming languages, a shell lets you define variables. So to create a variable, you simply put in the name of the variable, which we can call n, and you're going to have an equal sign, and you're going to give it a value. So let's give it John. And if we press enter, the variable gets created. So for example, if we want to access the variable using the echo command, we can pass an echo followed by a $sign, then the name of our variable, which is n. And if we press enter, we get John displayed. Now the variables we create are local to the shell, meaning if we close this window and open up a new shell, the variables would not exist anymore. If we want our variable to be accessible outside the current shell, we have to use the export command. So if we use export followed by n, and if we press enter, now if we close this shell and open a new terminal, we should still be able to access the n variable. Now let's create our first shell script. So we're going to use vi, and we're going to give it a name. Let's just give it simple. And if we press enter, we get inside the text editor. To go to insert mode, we're going to press I. Now in here, when you start your shell script, the first thing you need to do is put in the line hash followed by an exclamation mark /bin/bash. And under here, you can start writing your script. The first thing we need to see is the hash character, which is used to write comments. So we can type in this is a comment. And when we run our script, this line is going to get ignored since it's a comment. Next, we're going to use the echo command. So we're going to have echo followed by the text, the number of arguments is, and in here we're going to pass in a variable. So to get the number of arguments, there's a special variable you can use, which is the hash variable. So what this is going to do is it's going to print out the number of arguments we pass with our script. Next, we're going to have another echo command, and we're going to have the text, the arguments are, and another special variable is the asterisk. So we're going to have asterisk. This is going to print out all the arguments that we have passed. Again, with each variable, we're using the $sign. So it's going to tell our script that we want to substitute in a variable. Next, we're going to have another echo command with the text, the first argument is, and now to access the first argument, we're going to use $sign followed by 1. If we use $sign 2, we get access to the second argument, $sign 3 to the third argument. In our case, we're going to access the first argument. Next, we're going to have echo, and we're going to have the text, enter a number. So this is going to prompt the users to enter a number. And if we want to read from the keyboard, we're going to use the read command, and we need to provide a variable where we want to store whatever the user inputs. In our case, we're going to store it in a variable called number. And finally, we can print this out using echo and the text you entered followed by the number variable. Now, if we simply pass number, echo is going to display you entered number. But if we want to pass in the number variable, we need to use the $sign. Now we can save our file by going back to command mode using the escape button and pressing colon followed by X and pressing enter. Now if we list out the files we have, we can see that the simple file has been created. Now before we can run our script, if we look at the permissions, we can see that the owner of the file does not have execute permissions. So to run our script, we need to add execute permissions to the owner of the file. In order to do that, we're going to use change mod, and we want to access the owner of the file, and we want to add execute permissions. So now if we do ls-l again, we can see that the owner of the file has execute permissions. Now to run our script, we simply pass in / followed by the name and pressing enter. Now since we provided no arguments, we can see that the number of arguments is 0. And if we enter a number and press enter, we get you entered 123. Now we can run our script again, but this time we're going to pass in 2 arguments. And now if we press enter, we can see that the number of arguments is 2, and the arguments are hello world, and the first argument is hello. And again, we can put in a number, and it gets printed out. When we want to make decisions in our script, we can use conditional statements. So we can have if then else statements, and the syntax to use them is as follows. So we're going to have if followed by a square bracket. Since the square bracket is a command itself, we need to make sure that we have spaces around it. And inside the square brackets, we're going to have a condition. And using the then command, we can execute a statement for when the test or the condition is true. And we can have an else statement that is going to execute if the condition is false. And finally, we have to close the if statement using the fi command. Some of the common conditions we can have is the -s, which checks if a file exists and is not empty. We can also have -f, which checks if a file is ordinary. We can have -d, which checks if a file is a directory. And we can have the different permissions like -r, -w, and -x, which check if a file is readable, writable, or executable. We can also compare different values. So we can have -eq to check if 2 variables are equal. We can have -ne to check if 2 variables are not equal. We can have -lt to check if one variable is less than another. We can have -gt to check if one variable is greater than another variable. We can have -le to check for less than or equal to. We can have -ge to check for greater than or equal to. We can also compare different strings. So we can have the equal sign to compare 2 strings that are equal. And we can have the not equal sign, which is an exclamation mark followed by an equal sign to check if 2 strings are not equal. When we want to repeat a specific task multiple times, we can use loops in our script. So we can have either a for loop or a while loop. So to see this in practice, we're going to create a new script and we're going to call it sort text files. And we're going to press I to go to insert mode. And the first line is going to be #bin/bash. I forgot to explain what this line does in the previous section. So the hash followed by an exclamation mark is a special character sequence. It's going to tell our system that we're going to be writing a script that is going to get interpreted by the bash shell. So inside our script, we're going to have a for loop. So we're going to have for f in, then we're going to pass in all the text files using the wildcard. And for each file, we want to do the following. So first, we're going to echo out the file that we're sorting. So we're going to have sorting file, and we're going to pass in the f variable. So f is going to represent the current text file. Next, we're going to use the cat command, and we're going to pass in the file that we're currently working with. And we're going to use the pipe operator, and we're going to pass it to the sort function. And we're going to redirect the output to a file called whatever the current file is, .sorted. So if the file name is hello, we're going to create a new file called hello.sorted, which contains the contents of the file hello, but in sorted order. And finally, for confirmation, we can echo the text, sorted file has been outputted to the new file we created. And once we are done, we're going to have the word done. And now we can exit out of insert mode. And we're going to save our file and exit out. If we use the ls-l command, we can see that, again, we do not have execute permissions. So we're going to use change mod. And for the owner, we're going to add execute permissions for the file sort text files. Now if we run ls-l again, we can see that we have execute permissions. So to run the command, we're going to have // sort text files, and we're going to press enter. So as you can see, first it's sorted the file a.txt, and the output gets stored to a.txt.sorted. Now if we check the contents of the file b.txt, we can see that we have random letters that are not sorted. But if we check the b.txt.sorted file, we can see that the random letters have been sorted. Now let's look at another example using a while loop. So we're going to create a new file called checker. And we're going to have bin bash. And we're going to have a while condition, so we're going to have while true. We want to do the following. So we're going to have an if statement, and our condition is going to be -s input.txt. So what this is going to check, since we're using the -s option, it's going to check if the file input.txt exists and if it has content inside it. So it's going to check if a non-empty file called input.txt exists. If it does exist, we're going to echo out input.txt is ready, and we're going to exit our program. And finally, we need to close our if statement. And if that is not the case, that means a non-empty file called input.txt does not exist. In that case, we're going to echo out waiting. And we're going to also add a delay. So we're going to use the sleep command, which is going to add a delay, and we're going to give it 15 seconds. So it's going to have a delay of 15 seconds between each check. Finally, we need to close our while loop with the word done, and we can save and exit our file. Now to change our file to an executable, we need to use the change mod command, and we need to give the user or the owner of the file the execute permission. Now we can run the checker script. Now if we simply run it, we're going to get waiting, and we won't have an opportunity to create the input.txt file. So instead of simply running the checker script, we're going to run it in the background. And in order to do that, we saw it in the previous section, we have to use the ampersand character. And now if we press enter, we get the text input.txt is ready. That is because I already have a file called input.txt, which we can remove. And now if we run the checker in the background again, we get the text waiting. And after 15 seconds, we're going to get the text waiting again. That is because we added a delay. And now if we create the input.txt file and we put in some text, since it has to be non-empty, and we exit out, now if we wait a bit, we get the text input.txt is ready. The final concept we're going to see is the use of single quotes to capture the outputs of different commands. So we're going to create a new script called word count, and we're going to have bin bash. And let's say we want to count the number of lines of a file, which we're going to pass in as an argument. So we're going to have a variable called lines, and we're going to set it equal to forward single quotes. And inside the single quotes, we're going to have our command. So to count the number of lines, we're going to use the word count command. Now, normally this command would count the number of words, but when using the L option, it counts the number of lines. Now we want to count the number of lines of the first argument. And in order to access the first argument, we're going to use the special variable, which we saw before, which is going to be $1. And once we have the line count, we're going to echo the file named, followed by the name of the file, has, followed by the lines variable, lines. Now we can exit out and save our file, and we're going to change the owner permissions to have the execute permission. And now if we run the word count script, and as an argument, we're going to pass in a.txt. And if we press enter, here we're getting the file name a.txt has 1 a.txt lines. We're getting the extra a.txt because that is how the word count command displays its output. We can try another file, so we're going to have word count, and we're going to pass in the file d. And if we press enter, we get the file name d has 13 lines. So this has been a full beginner's guide to the UNIX system. Thank you for watching, and don't forget to like the video and subscribe to our channel for more programming content.